All right, here we go. Quiet, please. Okay, so the first, the little bit of notes up there, is we're going to have two inequalities now, and they're going to be connected by either the word and or, and that's going to form a compound inequality. So for example, this first one here where it says and, it says the word intersection below it. And so on the graph, when we graph these, we're going to be looking for an intersection which is going to represent like an overlapping region or a double shaded part. So this intersection right here, again, we're looking for the overlapping region. All right, so then you can see here we have two inequalities connected by the word and. So if I were to graph those, let's do, well, let me do it on the side, then we'll put it on the final number line down there at the bottom. So let's do, I don't know, let's do this one in blue. And we're going to do it on a number line over here. So we need x's greater than 2. So we would put 2 on our number line. Again, we'll do this one in blue. So we'll put 2 on our number line. And then is that an open circle or closed? Open. Yeah, it's open. Shaded which way? All right, so it'll be an open circle shaded to the right. Well, then this other one, let's do this one in green. So that one we got to put 6 on our number line. Now, I'm not really worried about the scale here, but 6 is definitely to the right of 2. So you have to have these numbers in order left to right on your number line. So 6 is going to be over here somewhere, right? And is that one going to be open or closed? That's open. So we got an open circle shaded which way? To the left. Okay? Now, do you see an overlapping region there that's double shaded, that's both green and blue? And then, do you see that would describe that region right here? And I'll get into this more formally when we do the problems. But that would be all the x values between 2 and 6, right? And so your final graph, you want to put 2 on the number line. So we'll just put 2 here. Let's put 2 right there. And then we'll put 6 right here. Doesn't have to be to scale. And we'd have the open circles at 2 and an open circle at 6, and then it would be shaded in between like that, right? So it's kind of like you take this graph right here, and you only graph the part that's double shaded. The double shaded part would be in between here, right? So really that statement right there, I'll get into this, like I said, I'll get into it more. That's like a between this statement. It's all the x's between 2 and 6. All right, well, let's look at the other one where it has the word or. So this one. Now it says an or, instead of being an intersection, it's a union. And what that's going to mean is that's going to mean anywhere that's shaded. So let me write that note for you. So that's anywhere, see if I can write a little neater. Anywhere that is shaded. All right, so let's do this one. So again, we'll do the blue and green thing here. So in blue, we got x is less than 2, and then in green, let's do the x is greater than 6. And again, they're connected with the word or. So let's put 2 and 6 on our number line. So in blue, let's put 2 right here. And then open or closed? Open. So it would be open, shaded which way? Yeah, it's to the left, yeah. And then we'll put 6 on our number line in green. And is that open or closed? Yeah, that one's open also. So we'll draw an open circle at 6 and shade it which way? To the right. Do you see how there's no overlap? That's an OR, okay? So your solutions would be all the x's that are less than 2 or all the x's that are greater than 6. But again, you'll kind of see how this all works out when we do the problems. So let's do the problems. So let's do, I'm actually going to do 1 and 3 first because those are ands. And then I'll do the 2 and 4 afterwards. Those are the ORs. So the first thing you guys got to see here on this one, on number 1, do you guys see that that's really 2 inequalities? If I kind of, let me do this for a second for you guys. Like if I scribble that out right there, do you see that that's 1 inequality there? -5 is less than x plus 1. But then you could scribble this out over here and you'd have a different inequality, right? That would be x plus 1 is x plus 1 is less than 2. So there's actually 2 inequalities there and they are connected by the word and. Now how I'll kind of show that is I'll do like, we'll circle them in different colors. So let's look at this one first. So that one says -5 is less than x plus 1. So we're going to have to solve that one. And, so put that word in there. And we're going to have to solve this green one here, which is this one. That one says x plus 1 is less than 2. So don't be confused by these, okay? They're just like what we were doing. You just got to do 2 of them, that's all. So both of these would have the same steps, right? So on both of these, to get x by itself, you would subtract 1 on both sides. So subtract 1 here, subtract 1 there, that's 0. And then subtract 1 here, and subtract 1 there, that's 0. So then on the blue one, you would end up with -5, take away 1, that's -6, is less than x. And on the green one, you would end up with x is less than 2 minus 1 is 1. This one on the blue side, we probably want to switch that around so we can look at it. So put the variable on the left and the number on the right. Again, it was pointed towards the -6, so it's going to go this way, right? So we just got to graph both of those. So let's do that. And I'm going to graph it. I'm going to do this like I did on above there. So we're going to do this. I'm going to make my number line here first. So my 2 numbers are -6 and 1. Again, they don't need to be to scale, but -6 definitely needs to be to the left of 1, right? Like that. And then in the blue, this one, open circle or closed? Open. So it's going to be an open circle going which way? To the right. And make sure you go past the 1 there. So go all the way like that. And then the green one, open or closed? Again, we're looking at this right here. So yeah, that's open. And we're going which way? Shade to the left. So where's the double shaded part? Where? Yeah, in between -6 and 1. It's the part that's green and blue, right? All right, now let's graph it first. So the final answer they want then is they want the -6 on the left. They want the 1 on the right. They're both open circles. And the double shaded part is just this part, right? So it looks like that. But then there's a way to write this solution also. So the way you write it, do you see how you got -6 on the left? So put -6 on the left. And you got 1 on the right, so put 1 on the right. And then all your solutions for x are the numbers that are between those two, right? So put the x in between, the -6 and 1. And then it's always a less than and a less than. All right, that'll do it right there. So that's how you write the solution like this. And then that's how you graph the solution right here. But again, that statement that I did right here, that's a between this statement. That says all the numbers x in between -6 and 1. So again, just put the smaller number on the left, the larger number on the right, put the x in between, and then put a less than, and you got it. All right? So same idea on number 3. So let's do that one next. So number 3, we're going to do the same thing. So we got 2 inequalities here again. So I got a blue one, which would be this one. And then I got a green one, which is this one. So let's set both of those up. So in blue, I got 8 is less than 3x minus 1. And then I got to connect that with the word and. And then the other one in green is 3x minus 1 is less than or equal to 11. All right, and we just saw both of those. So what's the first step on one of those? Trying to get x by itself. All right, we're trying to get this x by itself. So how do I get rid of that 3 and that minus 1?
Add 1.
Yeah, add 1 on both sides. So we're going to add 1 here and add 1 there. Well, it has the same steps on this one over here. You still got to add 1 there and add 1 there, right? These cancel out. These cancel out. So now in the blue, I got 9 is less than 3x. And in the green, I've got 3x is less than or equal to 12. And then how do I finish both of these? Got to get x by itself.
Divide by 3.
Good. So I got to divide by 3 on this side. I got to divide by 3 on this side. Those cancel out, make a 1. I got to divide by 3 on the right. I got to divide by 3 on the left. Those cancel out, make a 1. 9 divided by 3, that's 3. So I get 3 is less than x. But again, I don't like to write it that way, so I want to write it with x on the left. So put x on the left and 3 on the right. It's still got to point towards the 3. So that way. So there's that one. Then the other one over here, I just didn't write down the final answer. This one will come this way. So I got x is less than or equal to 12 divided by 3 is 4. So that's the green one. And let's put them both on a number line. So I'll kind of put that in here. I got to be able to see this thing now. All right, so I got, my two numbers are 3 and 4, right? So I got 3 on the left and I got 4 on the right. The blue one here, open circle or closed? Open, shaded to the right. So in blue, I got an open circle shaded to the right at 3. And then the green one, open or closed? That one is closed because of that equal to bar right there. So at 4, I got it closed, pointing which way? Right. Yep, shaded to the left. So I got a closed circle shaded to the left. I kind of lost my blue part here, though. There. So again, we're looking for the overlap. So the overlap's between 3 and 4, right? So our final solution is going to look like there's a 3 open circle at 3, and then a closed circle at 4. And the double shaded part is in between them, in here. All right, and then we got to be able to write that solution. To write that solution, you put the 3 on the left, you put the 4 on the right, you put the x in between, you make a less than, but which one has the equal to bar on it? Yeah, you have the solid dot at 4 right here, right? You got the solid dot at 4, then you're going to need the equal to bar right here. So it's going to be like that. So that's how you write the solution. Now, like, how would you check your answers on this thing? So this is your solution. This, like when you solve an equation, you get like x equals 5, right? That's what this is right here. That's writing your solution. And then this is graphing your solution, but they really mean the same thing. So then, if you wanted to check your answer, what you've got to do is you've got to, get this in here, you have got to make this inequality true and make this inequality true at the same time. So if I pick a number in the shaded region, it should make this thing true. Okay? So give me a number in the shaded region here. 3.5. So if I put 3.5 in right here, then I should get a true statement. So let's do that real quick. You don't have to write this down. I'm just going to write it down real quick. So you'd have 8 is less than. Well, then right here, we're going to do 3 times 3.5. So that's 10.5. 3 times 3.5, that is, that's 10.5 minus 1. That'd be 9.5, right? And then we'd still have less than or equal to 11. You see how it makes both of them true? Is 8 less than 9.5 less than or equal to 11? Yeah. 8 is definitely less than 9.5. And 9.5 is definitely less than or equal to 11. Now, what about when you look at this thing here? Would 4 be part of the solution? What do you think? This one's got an open circle. This one's got a closed circle. Which one do you think is part of the solution? The open circle or the closed circle?
Open.
Well, the closed circle is part of the shaded region, right? Because it's shaded in, right? It's a closed circle right here. So 4 should be part of the solution if it's got a solid dot there. Let's try putting 4 in there. So we want to put 4 in right here. And again, you don't have to write this down. I'll just do it real quick. So if you put 4 in right here for this x, what's 3 times 4? 12 minus 1. What's that? 11. So you would have 11 right here. Is that thing true? This thing right here? Is 8 less than 11 a less than or equal to 11? Well, is this one true? Yeah, 8 is less than 11. What about this one? Is this one true? Is 11 less than or equal to 11? Remember, it's a less than or equal to. So is 11 equal to 11? Yeah, then it's part of the solution. All right, so 11 is less than or equal to 11 because it's equal to. Anyways, that's an idea how you would check your answers, okay? What about if you picked a number, over, give me a number over here somewhere. 2. Well, 2 will work for the green one, but it won't work for the blue one because 2 is in the green shaded region. So 2 will make this one true. But we're trying to make this one true and this one true at the same time. So 2 will not do that. 2 will only make the green one true. What if I pick a number like over here somewhere? 5. If you put 5 in, that's in this blue region over here. 5 will make this blue one true, but it won't make the green one true. All right, and we only want the numbers x that make both of them true at the same time. So that's all the numbers between 3 and 4, including the 4. All right, enough of that. Let's do the OR ones. So we got 2 OR ones to do. And the last 2 are really quick. And there's no word problems today. So let's do number 2. Well, this one is already separated into 2 inequalities. Do you see that?
Yeah.
You don't have to separate it yourself. You just got to solve them both. So this is all ready to go. So how do we get this t all by itself here? What's that?
So, no. Minus 8.
Good. Dewan said minus 8. Because we're trying to get the t all by itself. So let's do that. So we'll do this one in blue. So we're going to do minus 8 on this side, minus 8 on this side. Well, the other one you'd solve the same way, right? So minus 8 on this side and minus 8 on that side. Then these cancel out. These cancel out. And in the blue there, I get t is greater than or equal to 7 minus 8 is negative 1. And then I got the word or in the middle. And then in the green there, I get t on the left. And that is less than 2 minus 8 is negative 6. And then we just graph both of these and we're done. So we got to put these numbers in order on the number line. So what goes on the left? Negative 1 or negative 6? Negative 6. So we're going to put negative 6 in the green here. So there's negative 6. And then we got, in the blue, we got negative 1. That would go over here somewhere, right? Again, those do not have to be to scale, but they do have to be in order left to right. So on the green one here, open circle or closed circle?
Open.
Shaded to the left. So in the green, open circle at negative 6, shaded to the left. All right. Then in the blue, open circle or closed? Closed. So we got a closed circle at negative 1, shaded to the right. So do you see how there's no overlap? Well, that's because on an or, that's a union, and we're just looking for anywhere that's shaded. So those are the two regions that are shaded. That's it. Because again, what we're doing here on an or is we want the numbers x that are a solution to this inequality or that are a solution to this inequality. So they don't have to solve both of them at the same time. We're just looking for solutions for t, I should say. We're looking for solutions for t for this inequality, or we're looking for solutions for t for this inequality. So if you pick a number over here, give me a number over here. Oops, hold on. Gotta undo that. If you're looking for a number over here, give me a number over there. Negative 7. That will make the green one true. That'll make this one true. That's okay, because we're looking for a solution for either inequality. All right, doesn't have to solve both of them at the same time. Give me a number over here. 1? 1. No, negative 2 would be there, Dawn. 1. All right, so 1 would be in this blue shaded region. Well, 1 will make t equals 1, will make this one true. Again, we're looking for solutions for t that either make this one true or make this one true. Doesn't matter which one. And then give me a number in here. Negative 5. Negative 5 doesn't make either one of them true. All right, that's why it's not in a shaded region. Remember, the or the union is anywhere that's shaded. So your solution, you don't have to write it a different way. You don't have to combine it into one statement. Your solution is just this. That's your solution. And then this is your graph. That really means the same thing. That's the graph of your solution. All right, let's do the last one without all the explanation here. All right, so let's do this one pretty quick. How do I solve the one on the left?
No. Divide 4 on both sides.
You divide by 4 on both sides. How do I solve the one on the right?
Divide 3 on both sides.
Yeah, divide by 3 on both sides. And then in the blue there, I'll have x is less than or equal to 5, connected with the word or here. And then on the right, I have x is greater than what? 7. So then the one in the blue, well, let me put my two numbers on there first. So in the blue, I got 5. In the green, I got 7. So then the blue one, open or closed?
Open.
Hold on, I'm right here, this one.
Oh, close.
That's closed, shaded to the what?
To the right.
Shaded
To the left.
to the left. So closed, shaded to the left. So we got a closed circle at 5, shaded to the left. And then the green one, open or closed?
Open.
Open, shaded to the,
Right.
all right, so we got a open circle at 7, shaded to the right. And that's it, we're done. All right, because the solution again is this thing right here. And then the graph, of course, which means the same thing, is right here. All right? Is 5 a part of the solution? Yes, because it's got the solid dot. What about 7? Is that part of the solution? No, because it's got the open dot. So the solutions are all the x's that are less than 5, including 5, or the x's that are greater than 7. All right, then the last two will go really quick. The last two, all I got to do is draw a picture for you guys, and you got to write down the inequality for me. So let's try this. So let's say I got one. Let's say this is a closed dot right here at negative 13. And this is an open dot right here at 5. And then I shade this in between here.
You just want to write it, or write the inequality.
Now, how do I write the inequality for that? That should be one statement. Anybody want to take a shot at it? What do I write? Rachel, what do I write?
X is, I'm sorry, 13, negative 13.
Negative 13.
Less than or equal to X, which is less than 5.
Good. That's it. That was perfect. Now, did you see how she did that? So to go through what I did before, is you put negative 13 on the left, because that's the number on the left. You put 5 on the right, because that's the number on the right. It's all the x's in between, so you put x in between. And then you make a less than and a less than. But then you just got to note that you have a solid dot at negative 13, so you got to put the equal to bar on that one. That's it. So that's all you had to write. And then number 5, sorry, 6. I got to do one more of these. What did I do on that one? Okay. So this one will go, let's do open circle at, I don't know, what do we want? Negative 7. Shade that way. And let's do a closed circle at 10 going this way. Anybody want to take a shot on how we write that one? There's no overlap here. So you got to write two separate statements. What word goes in the middle? Or. So you know there's going to be an or in the middle. So might as well put that in there. So then how do I write the one on the left, Neve? X.
Is less than negative.
Good. Yeah, just x is less than negative 7. And how do I write the one on the right? Who's got that one? Brian, what do you got?
X is greater than 10.
One more thing, though. It's got a solid dot at 10, so what do I got to put?
X is greater than or equal to 10.
Yeah, it's got the solid dot at 10, right? So if it's got the solid